Alright, another interesting curve. So let's have a look at y dash. So y dash is 2/3 x to the, if I minus 1 I get negative 1/3. So if I write that as a fraction, I've got a cube root of x on the bottom. So that's y dash. So first of all, I can see a couple of things. I can see that this is going to be an even function. If I put sub in negative x, if I square it first, I get x squared and then cube root it. So I can do that, no problem. So it's an even function. Also, if I put x equals 0 in, I get y equals 0. So straight away, I might put what I know in. So I know 0, 0. And just think it's going to be symmetrical about the y-axis because it's an even function. All right, let's have a look at, we're interested in x is 0, so let's look either side of that at y dash. So when I have 0 in, if I try and put 0 in here, you can see it's undefined at that point. Yeah, undefined. So we don't have a gradient function at that point. It's some sort of critical point. So it's a point of discontinuity for y dash. Let's have a look at negative 1. If I put negative 1 in, I get a negative 2/3. If I put a positive 1 in, I get a positive 2/3. So you can see it's going to be a decreasing slope on this side and an increasing slope on that side, which makes sense because it's an even function. All right, what else do we know? All right, so let's look at x as it goes towards 0 from the right. So it's going towards 0 from the right. What does y dash do? So here's y dash. So it's getting smaller and smaller. That x value is getting smaller and smaller and smaller. So this y dash value is getting bigger and bigger and bigger. Yep. What about as x goes towards 0 from the left side? So this side, you can see y dash, well, same thing. It's getting bigger and bigger and bigger, but we're putting negative x values in there, so it's going to be a negative number. So it's negative infinity. So the gradients of both, the gradients are getting steeper and steeper and steeper, so almost vertical. But one is a positive gradient on the right-hand side, and on the left, a negative gradient. So try and imagine what that looks like. And it's, so it's an even function. So it's what we call a cusp. So at the origin, this is going to be going like this. So it's almost like at that very 0 point, it's almost a vertical gradient. It's actually undefined, but vertical, and a positive gradient, whereas this, you can see, comes from an almost vertical but negative gradient. Okay. Now the other thing we know is, of course, ones. If we sub in x equals 1, we'll get y equals 1. So let's pretend it's going through 1, 1 there. And if we put negative 1 in, it's going through, so negative 1, it'll go through 1 as well. So, because it's an even function, so we know that bit. All right, let's have a look at what happens as x goes to infinity and as x goes to negative infinity. Whoops. What happens to our y dash? We know already that just looking at our normal function here, our function, as x gets bigger and bigger and bigger, so does our y. As x is negatively bigger and bigger and bigger, it doesn't matter, so does our y. So they're going to infinity, but if we look at y dash, as x gets really, really big, y dash goes towards 0, doesn't it, for both those? So it flattens, so the gradient flattens. So we're looking at a gradient that flattens, doesn't get steeper, it gets less steep, but it's still going towards infinity. So there's no horizontal asymptote, it is getting bigger and bigger. It's just going there slower and slower, if that makes sense. But no horizontal asymptote. All right, I hope that helps.